So the world is going electric, right? And it's awesome. Millions of us are making the switch to EVs. But here's something you probably don't think about. How do those cars even get to us? Well, a huge part of that journey is a long trip across the ocean. And that voyage, as we're about to find out, has a very specific, very fiery risk. It's a risk that became terrifyingly real during one disaster at sea. Okay, picture this. February 2022. A massive cargo ship, the Felicity Ace, is out in the middle of the Atlantic, and it catches fire, and then it sinks. The loss wasn't just some number on an insurance form. No, as the Drive put it so starkly, we're talking about 85 Lamborghinis. Just gone. Forever, resting at the bottom of the ocean. And those Lambos, they were just the start. The total value of all 4,000 cars on that one ship? Over $400 million. Think about that. A single incident, a single ship, and nearly $500 million in value just vanishes. It's a brutal reminder of just how high the stakes are every single time one of these ships leaves the dock.
But honestly, the money isn't even the whole story. For car people, this is where it really hurts. We're not just talking about expensive cars. We're talking about irreplaceable cars. The entire final production run of the Lamborghini Aventador was on that ship. Gone. A super rare Honda Prelude that some collector was probably waiting years for. Gone. Classic Land Rovers, hundreds of Porsches and Audis. It's more than a financial loss. It's a loss of history. It's an absolute gut punch.
So you have to ask, right? What could possibly cause a fire so intense that it sinks a modern cargo ship? Well, investigators quickly zeroed in on the lithium-ion batteries in the electric vehicles that were part of the cargo. And that brings us to the real heart of the problem, a nasty little bit of chemistry called thermal runaway. So what exactly is thermal runaway? The key thing to get is that this is not your typical fire. It's a chemical chain reaction inside the battery itself. Imagine one tiny cell in that massive battery pack overheats. It fails, and in doing so, it generates a ton of heat. That heat triggers the cell next to it to fail, which triggers the one next to it. And boom, you've got this unstoppable self-fueling fire that basically feeds on itself from the inside out. And here's why that's so terrifying, especially on a ship in the middle of the ocean. Think about a regular gasoline fire. It needs oxygen, right? So you can smother it with foam or chemicals, cut off the oxygen, and the fire goes out. Simple enough? An EV battery fire, totally different beast. It's a chemical reaction. It generates its own oxygen, so you can't smother it at all. Plus, it's pumping out all these toxic, flammable gases. The only way to stop it is to cool it down, and that means dumping just an insane amount of water on it. Now, if this was just a rare, niche problem, maybe it wouldn't be such a big deal. But it's not. The scale of this challenge is exploding. At the end of 2021, we had about 16.5 million EVs on the road. The projection for 2030, over 230 million. That is a massive, massive jump. And every single one of those cars, or at least its battery, has to get from a factory to a customer. A lot of them by sea. The number of these batteries crossing our oceans is just going to keep going up and up and up.
Okay, so we've got a huge growing risk on our hands. So you'd think there would be some clear, global, unified safety rules for shipping these things, right? You'd be wrong. The reality is, well, it's a mess. We're dealing with a patchwork of rules, and the regulations are struggling to keep up with the tech.
Just look at this timeline. It tells you everything you need to know. The Felicity Ace disaster happens in February 2022. It's a huge wake-up call. So 2 months later, the main international maritime group decides, okay, we need to do something, but when are the actual new global rules going to be finalized? We're looking at a window between 2024 and 2027. Years later. In the meantime, you've got Europe and the UK basically scrambling to put out their own temporary guidelines just to plug the gap. And this is the whole problem. You end up with this patchwork of rules. You got different guidelines in different places, nothing is unified, and a real global standard is still years off. And why is it so slow? Well, because getting dozens of countries and massive shipping corporations to agree on new safety rules, especially ones that cost money, is a nightmare. So for a global industry where a ship might leave a port in Asia under one set of rules and arrive in Europe under another, this creates some seriously dangerous gaps. So while the people in suits are figuring out the regulations, what about the crews on the ships? What are they supposed to do right now if one of these high-tech fires breaks out? Well, the good news is that best practices are evolving, and they're evolving fast. People are figuring out new ways to fight a totally new kind of fire. Now, I know what you're thinking. Wait,
You pour water on an electrical fire, and normally that's a huge no-no, but out at sea, it's actually your best weapon. Remember, the goal isn't to smother the fire. You can't. The goal is to cool it. You have to suck the heat out of that battery until the chemical reaction just stops. And water is amazing at absorbing heat. Plus, you've got an unlimited supply all around you. Not only that, but spraying down the other cars creates this protective water barrier that can stop the fire from jumping from vehicle to vehicle.
So what does this actually look like in practice? Well, safety experts have basically boiled it down to a 4-step plan. First, you have to detect it, and detect it early. Smoke and heat detectors are key. Second, and this is super important for the crew's safety, you have to ventilate. Get all those toxic fumes and gases out of there. Third, you hit it with everything you've got. Cool it down with massive amounts of water. And finally, you contain it. Use things like special water curtains to build a wall around the fire and keep it from spreading.
And look, progress is being made. It's not all doom and gloom. The international regulators recently approved new rules for passenger ships that also carry cars, like ferries. These new rules, which kick in around 2026, will require things like better fire detectors, CCTV monitoring on the car decks, and even powerful water cannons. It's not a solution for the big cargo carriers yet, but it's a start. It shows the industry is waking up and starting to adapt.
So where does that leave us? What's the big picture here? Well, what we're really seeing is a collision. You've got this 21st century tech revolution, electric vehicles, smashing right into the centuries-old business of shipping things by sea. And it's forcing a massive, and frankly, long overdue, rethink of what safety looks like on the water. And really, this is what it all boils down to. We all love the idea of the EV revolution. The cool new cars, the quiet rides, the clean air. That's the exciting part. But none of that can happen on a global scale if we don't solve these boring, unglamorous, behind-the-scenes problems. The safety of our supply chain isn't just a side issue. It's the absolute foundation that this whole electric future is built on. So it really leaves us with this one big question. As millions and millions more EVs are getting ready to cross the ocean, are our supply chains actually ready for the charge? The cars are ready. The demand is there. But are the ships that carry them, the rules that govern them, and the crews that sail them, are they ready? That's the multi-billion-dollar question the entire world needs an answer to, and it needs one fast.